Okay, so analyzing the discriminant, the value of the discriminant is b squared minus 4ac. You can see b squared minus 4ac in 3 different locations here, but they're all 3 different situations. In the first column, b squared minus 4c greater than 0. If a number is greater than 0, what kind of number is it? If it's greater than 0, positive. So these are the positive numbers. Oops, I didn't mean that to be green. These are the positive numbers. If the discriminant is a positive number, then we can say that we have 2 real solutions to that equation. If the discriminant is positive, we know we have 2 real solutions. If I were to graph that equation, if I were to look at it as y equals instead of like equals 0, if I were to graph it, on the graph, we would have 2 x-intercepts. Now, this graph right here is just a generic picture. It's not like exactly every graph you'd ever get, because we could have it reflected or moved other places. But the concept here is that we would have 2 x-intercepts. The middle column, if b squared minus 4ac is equal to 0, so if it is 0, that would be one real solution. If we look at the graph, that one real solution where it crosses the x-axis, that would be one x-intercept, which is also the vertex. And again, it could be flipped down. It doesn't have to be facing up. This is just generic picture. In the third scenario, b squared minus 4ac is less than 0. That would be a negative answer. And if we have a negative underneath that square root, we get 2 imaginary solutions. These are the ones that will have an I in our answer. If we were to graph it and look at the graph, it would never cross the x-axis. There would be no x-intercepts for that one. So if it's imaginary solutions, there's no x-intercepts. So we have 3 examples. We're going to do the discriminant for each of these. We're going to determine how many solutions there are. So the discriminant, until you have it memorized, b squared minus 4ac. I'm just going to keep writing it down, and so should you, until you have it memorized. B squared minus 4ac is the discriminant. We have to do that with the first equation. B is negative 6. So 36 minus 4 times 1 times 10. So 36 minus 40 is negative 4. So my first discriminant is negative 4. So then we use our chart. If we have a negative discriminant, what does that tell us? 2 imaginary solutions. And we knew that without even actually solving it. So I also know that there will be no x-intercepts for this. If I made it into a graph, there'd be no x-intercepts. All right, the next one. Discriminant is b squared minus 4ac. So my b is negative 6. When I square that, I always get a positive number. Minus 4 times 1 times 9. So I get 36 minus 36, which is 0. So the scenario where the discriminant is 0, how many answers will we have? 1, and it will be a real solution. That would be 1 x-intercept if we were to graph it. And then the third one, we'll do b squared minus 4ac, which will be 36 minus 4 times 1 times 8. So 36 minus 32 is 4. That is a positive number. So we will have 2 real solutions. This is like the only scenarios that you could possibly have. When we talk about x-intercepts, you could have no x-intercepts, you could have 1 x-intercept, or you could have 2 x-intercepts. Those are the only scenarios that you could ever have. So how could I possibly get 1 imaginary solution? How could I get 1 imaginary solution? So I'll just go back to example 3 from yesterday. How did we get 2 imaginary solutions yesterday? We got 2. There's 2 imaginary solutions here. How did we get 2 imaginary solutions here? Well, we did quadratic formula. Why are there 2 imaginary solutions? Because of the plus or minus. Why is there only 1 answer for the previous question? There's a plus and minus in the previous example. Because we're adding and subtracting 0, which changes nothing. So going back to my question, how can I get 1 imaginary solution? No, because that's 1 real. If you're adding or subtracting 0, that's 1 real answer. How can I get 1 imaginary answer? Do you think you know? You can't. That's totally what I'm asking here. You never, ever can have 1 imaginary solution. Never. Because in order to get imaginary, we have to do plus or minus square root. I mean, that's the formula. You got to do plus or minus square root. And then when we do b squared minus 4ac, we get a negative number. That's the only way possible you can get an I. But the only way possible you can get an I is having a plus or minus. You will always have 2 imaginary solutions. You will never have 1 imaginary solution. So this, what I was saying before, these are all the scenarios you'll ever have. So not once should anybody write, ooh, 1 imaginary. If you're going to guess, don't guess that one. This is it. This is all you have. So now you're going to take a few minutes, and I have 7 through 12, 6 questions of you finding the discriminant and saying how many solutions. I'm going to walk around and help you and check your answers by looking over your shoulder. I have all of these completed. I know that wasn't enough time for every single person in here to try every single question. For the ones that you did try, please check your answers. If you got something wrong and you can't read my writing because it's kind of zoomed out pretty far, raise your hand, or I can come. If you're not sure what you did wrong, I can look at your work. But check the ones that you did get done. Let's see what questions we have. A lot of you are making silly, just like arithmetic mistakes, like on number 8. There were multiple people that told me 4.5 instead of 2. So we need to understand how to multiply 4 times a half rather than adding them. And then a lot of people were missing when we've got multiple subtraction signs or minus signs, how they turn into positive or they stay negative. Do you have a question? I'm a little bit in the way, I know. So some of our biggest problems in here might be are just like basic multiplication skills. That's where I encourage you to try it without the calculator so you get better at multiplying. The calculator will always be there. But like, in order to make yourself smarter, you have to not use the calculator. It's so hard to try. Who has questions? I'm not going to give you enough time to just copy my answers down. That's not going to help you at all. Who has questions? Okay. So here's a fun little challenge. Find a possible pair of integer values for a and c so that the equation ax squared minus 4x plus c equals 0 has one real solution. And then write the equation. Find a pair of integer values for a and c. So that the equation ax squared minus 4x plus c has one real solution. How would we know how many solutions this equation has? How can we find out how many solutions this equation has? Hint, we learned it today. We find the discriminant. So what's the discriminant formula? B squared minus 4AC. All right. Do we know something from B squared minus 4AC from this equation? We know B. So let's make this 16 minus 4AC. If this is going to have one real solution, what does 16 minus 4AC have to equal? Has to equal 0. So I'm looking for an A and a C that makes that true. Do you already have one, Nathan? You look like you already have one. I bet you can come up with one real fast.
4.
Hold on. I'm looking for an A and a C.
4 and 1.
A is 4, C is 1. Yes, that works. What's another one? Somebody different. What's another one? People are talking about, I don't know who's talking. Amy. 1 for A and 4 for C? Sure. Give me another one. 2 and 2? Give me another one. Corey? Yes, -2 and -2. -4 and -1. Any others? -1, -4, right. All those would work. So there are like multiple different answers that were possible for that one. Okay, so here's a concept summary, but I've actually gone over this quite a few times in the past couple of days. So there are 5 different methods for solving quadratic equations. 5 methods. Graphing. When would you ever want to use graphing? Maybe if the graph's already given to us? Sure. I'm not going to want to make a graph to solve. Maybe if I'm completely lost and I forgot how to do everything else, maybe I'll start plotting a graph and look at the x-intercepts. That's going to be my last ditch effort. Graphing doesn't always work, though, because what if the answers are horrible decimals or imaginary? You're not going to be able to find imaginary answers on a graph. The second thing is using square roots, but that doesn't always work. That only works when something squared equals a number. It only works in a certain situation. Factoring, that one's going to be the fastest way. I'll prove it to you later. That one's going to be the fastest way, but it only works if it's factorable. Completing the square works every single time. Completing the square works every single time. But first of all, I did not teach you, even though I can, I did not teach you to do it when there is a number in this spot. So if there is a number in the A spot, you don't know how to do complete the square. I didn't teach it to you. And then if the B is odd, and we have to do that B divided by 2 square, if the B is odd, you're not going to want to do it that way because then it gets really messy. So they suggest that we use completing the square when the A value is 1 and the B is even. And then when would we use quadratic formula? Anytime you want. Anytime. But I will say factoring's way faster than quadratic formula if it's factorable. So you really don't want to spend hours doing your assignment because you refuse to learn factoring, and so you do everything by quadratic formula. That's silly. Complete the square is faster than quadratic formula as long as A is 1 and B is even. There's like better ways to do it, and that comes from experience. But there's some suggestions. We have one last example today, and this is it. And this is a real life application. Yay! We get to do a real life application finally. We finally learned enough to do a real life application. In real life, there are so many things in real life that involve throwing things and seeing how far they go, how long it takes to throw, how hard did we throw it. There's this entire part of the part of life called physics. You ever heard of physics? It's pretty important, okay? And it's used in a lot of careers. Careers that you might not even realize. It's used in a lot of careers. There is this standard equation, and this is it. And it has to do with if we have an object and we either drop the object or we throw the object. We could throw the object up. Did you see that parabola it just made?
Yeah.
Or we could throw the object down. That was part of a parabola. I used one that was kind of empty. I don't have a lot of objects to throw. Okay, so if an object is dropped, we use a specific formula, h equals negative 16t squared plus h sub 0. I'll talk about those pieces in a second. But if an object is thrown or launched, there's something extra. Because if I just drop something, it just falls from gravity. But if I throw something, there's velocity behind it. I'm like putting a force with it. I'm making it go faster, right? So there's this extra term in the middle, and the v, that's standing for the initial velocity at which something is thrown or launched. The h sub 0 would be the height at the time the object is dropped. So about right here, the h would be 5 feet, because that's about where my eyebrows are. Okay? So h sub 0 is the initial height. V sub 0 is the initial velocity. If we throw something up, velocity is positive. If we throw it down, velocity is negative. And then this h over here, that's the height after specific time. T is the time. There's a different equation that looks just like this, only it has like a negative 9.8 instead of the negative 16. And that's if we're doing metric system. But this, we're using feet, so we use this one. And then they have some examples of where you might have a velocity that's positive or velocity that's negative. I do not think that the velocity is 0 if you are launching an arrow, because that string has force. So this, I don't believe that. Here's our question. A juggler tosses a ball into the air. The ball leaves the juggler's hand 4 feet above the ground at an initial velocity, vertical velocity of 30 feet per second. Juggler catches the ball when it falls back to a height of 3 feet. How long is the ball in the air? So are we going to use the first equation with no initial velocity, or are we using the second one with velocity? Second one. So we're going to set up h equals negative 16 t squared plus, since he's throwing it up, we're going to go up 30 t plus he's starting at a height, h sub 0, starting at a height of 4 feet. The question is, how long is the ball in the air if he catches it at 3 feet? So our new height is going to be 3. To solve for t, we have a quadratic equation. You've got different methods to use to solve it. Because there's a 3 on the other side, I'm going to go ahead and subtract that. And so I will be solving 0 equals negative 16t squared plus 30t plus 1. And when I go through what methods I want to use to solve it, because it starts with a negative 16, I'm just going to do quadratic formula. All right? You guys ready? How's the song start? It does, but we don't have any X's. How's my song going to start this time? T equals opposite B plus or minus square root B squared minus 4AC all over 2A. Let me go to my other one because of time. I forget what that number is. Oh, 964 would be what's under the square root. 964 does simplify. I'm sorry, now I'm going fast because we're almost out of class time. It does, so going through the process of simplifying it, it does square root. So we've got 2 square root 241. There's a negative in the denominator, so we multiply the top and the bottom. And then we can factor out a 2. And so we get this 15 plus or minus square root 241 over 16. I didn't get to finish it. It's okay. This will be on the video if you need to go back and see this one. You guys have that assignment due on Monday. Have a wonderful weekend. Happy Friday. What? Night, Monday night. Yep, Monday night.